Hello, good morning. Today our lesson will be about properties of vectors. Our lesson is about properties of vectors, so let's see. So before we start, last time we did about some triangle law, parallelogram law, so these are properties. So let's see, we have in real math, we have like 5 plus 8. So if I have 5 plus 8, this can be written as 8 plus 5. So we call this one commutative property. In vectors, exactly the same way, if I have u plus vector v, this can be written as vector u v plus vector u. And we call this one commutative property of addition. If I had u plus v plus w, if two of them were inside the bracket, and then we can write this one as u plus v and then plus w. And this is called associative property of addition. If I have a scalar quantity or a number outside, k is a scalar, it's a number, u plus v, then I can distribute these ones here, ku plus kv. This is called a distributive property. Distributive property. So if I add any zero vector to any vector, I have always the same vector. This is called adding zero vector. So in some cases we cannot multiply vectors. So if I had, for example, let's say u is equal to 5 times absolute value of v. This does not make sense because this is a vector, this is a scalar. So a vector cannot be equal to a scalar. Therefore, this is no sense here. It has no sense. Or if I have u outside and then v plus w, I cannot multiply vectors. So a vector cannot be outside the two brackets here, the bracket here. So this has no sense because vectors cannot be multiplied. This can be only a number. Okay, so let's see one example of expressing vectors in terms of another one. So if I say write x and y in terms of a and b, in terms of a and b. So if the question was a, vector a is equal to 2 times vector x minus 3 times vector y, and b equal to 4 times vector x plus vector y. So I'd like to isolate x and y. So I can write x and y in terms of vectors a and b. First of all, what we say is like what we did in simultaneous equations, we have to eliminate one of this. So let's multiply the second equation by 3 so that we have the same y's. So this will be vector a equal to 2x minus 3y, and this will be 3b. I multiply the whole thing here. 3b is equal to 12x plus 3y. So now, since these are opposite signs for y and the same, we add. When we add this, we will get a plus 3b is equal to 14x. Therefore, x equals 1 over 14 a plus 3 over 14 b. So we express this one in terms of a and b. Let's do the same thing for y. To eliminate y, I would multiply this one. To eliminate x, I would multiply this one by 2. So that I have 2a. It's better to eliminate instead of substituting this one because you will have a lot of fractions. But it's easier to eliminate again the other variable. So 2a is equal to 4x minus 6y. And then we have b equals 4x plus 2y. So I'm multiplying this one here, so plus y, b is equal to that, plus y. So now I subtract because I have the same sign. So 2a minus b equal to minus 6y minus y, which is minus 7y. Therefore, y equals minus 2 over 7a plus 1 over 7b. So here y is written in terms of a and b. So that's one property we have, so that we can write vectors in terms of other vectors. Another property we have, we'll see, is a unit vector. So a unit vector, let's say I have vector of a unit vector of vector u. A unit vector of vector u will be always vector u over magnitude of u. This means unit vector in direction of u, on direction of u. So the direction of the unit vector is the same as the direction of vector u. And this is a unit vector, the magnitude will be 1. The magnitude of a unit vector is 1, and the direction will be the same direction as u. So let's see if I have, if angle between A and B is 50 degrees, find the unit vector in the direction of 2a plus 3b. That means I'm finding the unit vector of 2a plus 3b. The first thing I have to do is I have to find the magnitude of 2a plus 3b. I have to find the magnitude of 3a plus 2a plus 3b. To find this one, first I have to see, I have to visualize this one to draw it. So I have to have, this is, let's say, a. We are given, let's say, absolute value of a is 8. Absolute value of b is 10. So if this is 8, this is a, then I have 2a, which is up to here. Double of a, that's 2a. And then we have b, which is 10, a little bit longer than this. And then 3b will be 3 times this. This is 3b. 3 times the original vector. So now this angle is 50 degrees, angle between them. So I make a parallelogram here like what I did before. So we have this, and then this vector is 2a. So I have 3b plus 2a, commutative property, the same as 2a plus 3b. Therefore, this is my diagonal, which is sum of 2a plus 3b. So 2a plus 3b square is equal to square of 2a plus square 3b minus 2 times absolute value of 2a, absolute value of 3b, times cosine of this angle here. This angle is 180 minus 50, which is 130 degrees. Therefore, this will be a is equal to 8. So this will be 2 square is 4 times 64 plus 9 times 100 minus 2 times 2 times 3 is 6. Then we have 8 times 10 times cosine of 130 degrees, cos 130 degrees. So this will be equal to 538.9. Therefore, 2a plus 3b is equal to square root of that, 538.9. This is equal to approximately 23.2. Therefore, my unit vector will be the direction of 2a plus 3b over the magnitude of 2a plus 3b, which is the same as 2a plus 3b over 23.2. And this is the unit vector in the direction of 2a plus 3b. And this is a simple example. So to get always next topics, please subscribe.